Let's now discuss a second example of using conditional distributions to understand how some independent variable affects a dependent variable. So let's go back to the art museum example. Just to refresh your memory, go back to page 102, I guess. We've already discussed this a little bit. The question was, how does your income level affect whether or not you'd go to an art museum? So we looked at this through a crosstab. You can think about this as we studied conditional distributions by using the column percents. So if you are high, that's the independent variable, if you're high income, the chance that you go to an art museum is 39%. Whereas if you have low income, you have a 30% chance of going to an art museum. So we've used conditional distributions to understand how the likelihood of going to an art museum depends on your income. Now, the story was the higher your income, the more likely you are to go to an art museum. So 30% for lows, 35% for mediums, 39% or so for the high income people. We actually had more data. So that crosstab example dichotomized the art museum attendance variable into yes or no. But we actually had more detail than that, in that we knew how many times someone went to an art museum in the previous year. So in essence, to make that crosstab, I took this how many times you've been and put it into two bins, 0 versus 1 or more. We could analyze this same problem using the original variable. So here is what you would get from compare means in SPSS. This is actually the equivalent of compare means in SAS. So this is the output that you'd get, but it looks just like it in SPSS. So what we have is the distribution of the number of times you went to an art museum broken out by income level. By income is the way someone might say it. So there are 370 people with low income, 1,200 whatever with medium, and so forth. Now we can summarize that conditional distribution with a variety of summary statistics like the mean, the standard deviation. We could look at the min and the max. So let's just interpret all these numbers. The mean number of times that someone with low income goes to an art museum is about 0.89 times. Standard deviation is 3.8. The minimum number of times is 0, and the max is 52. Now, as I mentioned earlier, we usually are content by summarizing this with the mean. So let's just look at the means. And what you'll see is that the story is a little bit different than what we had with crosstabs. So those with low have a mean of about 0.89. Those with high have a mean of about 0.89. Question becomes, why are we coming to a different conclusion with this data set than with the previous analysis with the crosstabs? Well, the problem with a mean is that you don't get to see any other parts of the distribution. So it would pay to look at maybe some box plots. So box plots give us a much richer picture of the distribution. So here are the box plots. So the first thing to note is that the medians and the first quartiles are all 0. We could have concluded that from our crosstab because the percent who go for each of the three income groups is less than 50%, which means over half the people are zeros, and that's shown by the box plot. The first quartile for all three groups is 1. This illustrates a problem with the median that we've already mentioned last week, namely that it's very insensitive so the medians are all the same. We need something else to discern differences between these groups. The most interesting part of these box plots are the outliers. So what we see is that just about everything is an outlier in these distributions. I shouldn't say everything, but the plot is dominated by outliers. In particular, we see some very extreme values for the low income group. And that's confirmed by the results from compare means. So the max was 52. That 52 is sitting right here. This value happens to be a 45, and it's also very extreme. Now we recall that the mean is very sensitive to outliers. Just like the median is very insensitive, the mean is almost overly sensitive. So we can make the mean as large or as small as we want by just manipulating one value. So if you have one sufficiently large observation, you can make the mean as big as you want. So what do we do about outliers? Well, remember from last week, I said the first question you should always ask yourself is whether this is a correct but extreme value or whether it is a mistake. Now, if it's a mistake, you obviously want to get rid of it, since fix it if you can, but if you can't fix it, you don't want rubbish in your analysis. So I did some further investigation of that 52, and it turns out this is a 70-something-year-old widow, and I could see a widow visiting an art museum once every week. Maybe she's some sort of volunteer or something. So my conclusion is that 52 is plausible. Now then, the next question is, do we want the 52 to dominate our analysis, which is what it's doing here. It's inflating the mean of the lows. And my answer to that is I don't think I want one person inflating that mean or two people inflating that mean so much. So let's look at the trim means, and when you looked at trim means, you come to a similar conclusion as the one we arrived at from the crosstabs. The higher the income, the more times you go to an art museum on the average, at least on the trimmed average. All right.